Okay, good morning. This is your maths lesson for Wednesday, year 4. Okay, I'm just going to talk you through a little bit of it today, as we are continuing with area, but it's a little bit more complicated today than just counting squares. Okay, so you are going to start off with your form. So you're going to, it's about place value. Now, our forms are going to be slightly different for the next couple of days, as Miss Evans has found this awesome website that creates some questions for you. And it says A, B, C, or D. So all you have to do is calculate it. Oh, I'm showing you the answer for A there. Is calculate it and say A, B, C, or D. Okay? 8 times 0 is 0. Okay, so you have to just put A. So that's your starter for today. Then what we're learning to do today is we're going to problem solve with area. So if I wanted an area of 24 centimetres squared, what would my length and height have to be? Now, previously, we've been doing lots of arrays. Now, if you can remember how you find out the area, you do the length times by the height. This is how you find out the area of this bit here in the middle. So remember, the perimeter is the distance around the outside length, and the area is this little bit in the middle. So how would I find the area of this if I haven't got any measurements? Well, if you think that it's length times height, you've got to think about two numbers that multiply together to make 24. So we're going to think about our factor pairs. Do you remember when we did factor pairs? So if we were to find out if we wanted to get 24 as our total, what two numbers would we have to add up to multiply together? We could do 1 and 24. We could do 2 and, so this side here, I'll get another colour, could be 1 centimetre. And this side here could be and 24. It's probably going to be the other way around, as that one is a little bit longer. Okay, what about 2? What about if my square was a little bit smaller and I had 2 on this side, 2 centimetres? What would this have to be 24? 24 divided by 2. This could be 12 centimetres. We can have a look about where 24 is on our multiplication grid. Where else can you see the number 24? Excellent. It's in our 8 and our 3 times table as well. So we could say that this could be 3 centimetres and this could be 8 centimetres. So if we're problem solving and we want to try and find an area of 24, we can use our times tables. And you're going to use this in a little game a little bit later. Okay, so that's a part of our problems. Now you have got 3 problems to work your way through today, and I'm just going to go over some of them. I'm going to start you off and then you're going to carry on at home. So this one, Ron has 4 squares. He systematically makes rectilinear shapes. That's a really long word. Rectilinear. So that's where they're not quite equal, but they're in a rectangular form. Okay, rectilinear. Use 5 squares to make some rectilinear shapes. So you can get like 5 post-it notes, or you can cut out 5 squares. It's going to be quite practical today. You're not going to need lots of pens and paper. So you can just cut out 5 squares, 1, 2, 3, 4, 5, and you're going to make some rectilinear shapes. So that could be 1. That could be 1. I might then, oopsie. Oh no. Let's try that again. I'm going to duplicate these. Try and bring them back over here. There you are. I might change it around. I might have it like that. You might need a couple more than 5. You can either just have the same 5 and keep changing them around. Now I'm going to continue working systematically. So I might then like this. So I'm at the moment just moving 1 square to create different rectilinear shapes. Okay, see how many possibilities you can come up with. You can always email us how many possibilities there are just by having 5 squares. So it's a bit of an investigation today. All right, our second one is using squared paper. You can just use normal paper. To draw 4 different rectilinear shapes with an area of 12 squares. Compare with your partner. Are they the same or are they different? Again, it's an investigation, so you need to try and work systematically. So I'm going to get my line tool. And first of all, my first one I'm going to do is just going to be 12 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to go across like this, and it's going to be 12 squares. Have a think about what the perimeter is, because the perimeter is going to be double that. It's going to be 12 at 12 at 1 at 1. So the distance around the outside. You can always compare. You can compare the area and the perimeter. Okay, then I'm going to then work systematically, and I'm going to do it like this. But instead of having 12 right down there, I'm going to put that extra one on top. Okay, so you can work like that, or you can go completely random and you can say, well, there's 4 there, then I'm going to put another 2. So I've got 1, 2, 3, 4, 5, 6. I'll tell you what, I'm going to mirror that, and I'm going to do the same the opposite side. And let's double check. Oh, I've made an eye. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can go completely random if you want to. All right, so draw some different rectilinear shapes. That is another investigation that I'd like you to do. And then we've got a trickier one. Mo is building a patio made of 20 square slabs. What could the patio look like? So that's like what I was doing at the beginning. So you might not have to have squared paper. I think I might be squared. So in this instance, you've got to think about factor pairs that make 20. So I could have 2 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As we know that 10 times 2 is 20. Now 20 squares. What else can it look like? Well, how else can we make 20? You're going to investigate that. I've got lots in my head. See if you can investigate some. And then it goes on to a step further, and it says Mo is using 6 black slabs in his design, but none of them are touching each other. Where could they be in some of the designs you've made? So in my one here, I might get a colouring pencil, and I might put, well, I could put one here. I could put one here. 2, 3, 4, 5. I'm going to have to put one here. 6. Okay. I'm pretty sure you can do that if they're not diagonal. I just don't think they can be side by side or one on one on top of each other. So once you've done a little bit of investigation, I then have a game for you. Now, if you go on, there will be a link in on the Sway, but this is called Swimming Pool Sid, and you are looking for this website here, primaryapps.co.uk. Now, there will be a link, so you can just click on the link. Now, what it does, you can either work on perimeter, that's slightly harder, or you can work on area. So I'm going to choose a swimming pool. You can choose patio. And I'm going to do area today. Let's do 10 by 10. So let's start nice and easy. So this is easy, medium, and hard. Let's start easy. So it says, I want a perimeter of 42 meters squared. So I've got to think, if I go back to my times table, where can I see 42? Oh, there it is. So I could do a swimming pool of 6 times 7. So I could go 6 times by, oh, wrong way, 6 times 7. And then click next, and that is the area of the swimming pool. Okay. If I want it 12, I've got to think two numbers that multiply together make 12. 3 times, what am I going to say? 4. 3 times 4 is 12. That's our swimming pool. Okay, it's slightly easier doing the area. So that is all of your learning. Lots of area work to be getting on with. Well done.